To understand the stones, you first need to understand the problem. A fully loaded train is extraordinarily heavy, millions of pounds of metal and cargo. If that kind of weight were placed directly on the ground, the pressure would be overwhelming. The soil would compress, the rails would sink and warp, and eventually the train could derail. That's where the stones, officially called track ballast, come into play. It helps to picture the railway like a layered structure. At the top are the steel rails. These rest on horizontal supports known as ties. Beneath those lies the ballast. The ballast acts as a cushioning layer. Its role is to take the enormous, concentrated load from the train and distribute it across a much larger surface. Here's the interesting part. The tracks aren't actually anchored deep into the earth. If you look closely, they essentially sit on top of the stones. This allows the track to absorb vibrations from a passing train instead of cracking under the stress. Now you might be wondering, sure, stones carry the load, but why these specific kinds of stones? They're rough, angular, and not exactly pleasant to look at. You'll never find smooth, rounded river pebbles used on a railway. There's a precise engineering reason behind that choice. Think about what it would be like to step onto a surface covered in marbles or ball bearings. You'd slip and slide instantly. Instead, engineers rely on crushed rock, typically materials like granite or quartzite, broken into sharp, uneven pieces. When these angular stones are packed together, they don't roll, they lock into each other. The rough edges grip and hold, forming a stable, compact layer that stays put while still providing a small degree of flexibility. But the stones do more than just carry weight. They also defend against the railway's three biggest threats: weeds, water, and fire. You don't usually see plants taking over railway tracks, and that's no accident. This thick layer of coarse, jagged stones makes it extremely hard for anything to grow. If plants did manage to take hold, their roots could disturb the ground and weaken the track's foundation. Then there is the problem of water. If tracks were laid directly on bare soil or even on a solid concrete base, heavy rainfall would create serious issues. Soil can turn into mud, and that mud can wash away, leaving the track without proper support. Concrete, on the other hand, tends to trap water in puddles, which can lead to corrosion on the steel rails. A bed of stones solves both problems because it's highly porous, almost like a massive drainage system. Rainwater quickly seeps through the gaps between the rocks and flows away, keeping the foundation dry and stable. The stones also have fire prevention benefits. Unlike flammable materials, stones don't burn, so they act as a fire break. If uncontrolled vegetation grows nearby, sparks from passing trains, from brakes, wheels and exhaust could ignite wildfires. In that sense, the stones serve multiple roles at once. They support the load, prevent unwanted plant growth, allow for drainage, and are fire preventatives. You might also be curious why these railway stones are called ballast. The term actually comes from maritime history. Long ago, when wooden ships sailed without cargo, they were too light and unstable, tossing around in the waves. To keep them stable, sailors would load the ship's hold with heavy stones. This added weight was known as ballast. Once the ships reached port and were ready to take on cargo, those stones were simply unloaded and left behind. Early railway engineers, searching for an inexpensive and effective way to stabilize tracks, noticed these piles of discarded stones and realized they were ideal for the job. They began using the ship ballast beneath railway lines, and the name has remained ever since. So why are there stones along railway tracks? Those rough, angular and unappealing rocks are actually a brilliant piece of engineering. They support immense weight, prevent weeds from taking over, allow water to drain away, and prevent fires all at once. It's a simple but effective system, that has helped keep trains running smoothly for over 200 years. Click the video on your screen right now and I'll explain another everyday mystery you've wondered about your whole life but never thought to look up.